All right, welcome to week 10. This lesson is going to be a quick look at different types of databases that are in use out there. I'm obviously not going to cover all the ones, and this is just going to be an overview to get an idea. 'Cause we've been working with relational databases this entire course. So we're just going to talk about some of the other ones that are out there and what they're used for and why they exist. The main reason they exist is because relational databases just couldn't meet certain needs. So go ahead and start over here. One second. Let me get up. Slide deck up. And here we go. All right, so quick look at common database types here. Start with the first one, the most common we look at, relational databases. This is what we've worked on the entire course. The data is stored in two-dimensional tables that have fields and records, or you want to say columns and rows. Uh, Looks a lot like an Excel spreadsheet. That's why people confuse Excel as a database. Excel is not a database, it's a spreadsheet. The tables are connected through a key pairing of the primary key and the foreign key, which that's the relationships in relational databases. So when you're trying to join two tables together, you're joining off your keys, your primary and your foreign keys. Uh, there are two main types of relational databases. That's your OLTP, or online transaction processing. This, I always call this the cash register database. You think about, at Walmart, and you got to ring stuff up and all those registers going. It's got to make quick transactions. It has to write quickly to a database because every time you're writing a new transaction each time somebody buys something. So this is tuned for writing. It's tuned for, fast writing, quick writing. It's not really tuned for running reports off of. That's where the OLAP that goes for. That's the online analytical processing, and that is, you think of data warehouses, data marts. You may have heard that term. These are designed for analytics. They're designed to run reports off of. They're designed to, query the data, look through stuff, find records, all kinds of stuff. And if you work in data science or in any form of analytics, business intelligence, this is kind of the world you'll want to live in. And these things, they're tuned differently. They are actually denormalized. I know went over normalization in classes, and I got some videos on normalization I can link to. But so in the case of data warehouses, you actually denormalize the data because the normalization, the third normal form, is designed to help make writing faster. Denormalization makes reading faster. By instead of having to access a bunch of tables you join, what you'll have is very broad tables with lots and lots of rows, lots of fields that you can quickly read into that. But so that's the relational we've been working with. The next one we'll go over is hierarchical. Now this is probably the oldest one. I think this might predate relation database. I have to double check on that. But the hierarchical model base is very strict. It's and you cannot have many to one or many to many relationships, since the child and records can only have one parent. So you can see here, this is a good way to think of this as like if you want to look at a command structure for like a business, or when I was in the Army, you look at it, you'd have squads, and the squads would go to a platoon, and the platoon would report to a company. Your platoon can't report to more than one company, and your squad cannot be in more than one platoon. Or an employee, has a manager. Your manager maybe has a director. Typically, in a well-structured organization, you won't have more than one manager. We all know it sometimes feels like everyone wants to be your boss and tell you what to do. But believe me, I've been there. I know the feeling. But so this is what this is used for. It's very strict. It works very well if this is the only thing you're trying to do. If you're trying to have this hierarchical looking type of thing, it's I think IBM has the basis of it. They kind of started the whole thing, but you're not going to see a lot of it in use because it's kind of a one-trick pony. There's no key pair relationships like in a relational database. Instead, the relations are simply implied by the table structure. It's a tree, and you're looking down the tree. And like I say, this is very much a specified database, and that's what all these databases we're going to get into. These are databases that the relational database just doesn't do it for them. And like I say, I believe the relational database was designed to deal with the shortcomings of the hierarchical database. So the next one is a newer one. This is the inverted index. This one is more advanced. What this one is based off of is, and let's see if let me fix the screen here. I see I'm off center. There we go. An inverted index is used for what's called full text searches. So the documents, when they come into this database, they're heavily pre-processed, and they're indexed. And all this pre-processing you're doing before, which takes a lot of computing power and a lot of storage space or anything like that, what it does, it allows you to quickly look through full text of documents, quickly read through them fast. This is an element of what they call large language models, which are the functional basis behind things like Chat GPT and Google's Bard. So the idea here is that instead of just placing data like you do in a relational database, you just add a row. You'll add a document, and a document can be everything from a Word document to a book, web page, or all kinds of things can be documents. We'll get to document databases later down here. And instead of just storing it, this system goes through and it processes it. It says it reads it, what's this about? It'll give it up, it'll place it in a category. Oh, this is a how-to book, or this is about databases, or this one's about Python programming. And it really does well indexing so that you can quickly search across all these documents fast. And that's the power behind something like a Chat GPT, is that it can very quickly search all this information on the internet for you, and not only just find it like Google did, when Google came up with their algorithms, but read it and understand what's behind it. So that's chat. That's the inverted index, and the inverted index we're going to see is part of the document databases when we get there. Okay, so we have a graph database. That's next. Graph database. This is a very special purpose database based on graph theory that contains nodes, edges, and properties to find relationships between different entities. Now, the biggest place you find this, the most common place you're going to learn about this is in social media. So you have these nodes, we have nodes, edges, and properties. So these are the nodes. This is their properties, and this is their edges. They touch things. So person A loves person. So this guy, Dan, was born in 1970, got a Twitter handle, loves a woman named Ann. She was born in 1975. Ann owns a Volvo. Dan drives the Volvo. That's such a pretty good deal. He got her to buy her a car. He lives with Ann. They both love each other. So that's, and you can, this goes across multiple. So this is how, like, when you're Facebook or whatever else, I know I'm old, but your TikTok or Instagram or stuff where they can say, hey, you might know this person. This is how they find it, because it's, they go through layers and say, hey, you have 17 common associations with this other person. You might know each other. This is also used by law enforcement and within cybersecurity to reinforce, trace back connections to determine like ringleaders of criminal enterprises. And within, like, what I do in Verizon is, like, sometimes we find out that an exploit that has been sent out on, people are exploiting our system. We found a hole. Sometimes it's an internal job. And we got to go and we use these graph networks to find out where the initial information about this exploit came from. And that can kind of guide us back to who in our company may have let the world know about this. But so that is graph databases. Again, they are very specific use. You would not use them for regular database uses. These are just, they just wouldn't work good for regular database use. And the next one we got is a network database. So network databases are based on the ownership of records. And network databases allow for a record to have multiple owners. You can kind of view this as an upside down tree where each member branches to its own owner. The network data model was created to correct for the many-to-many issue found in relational databases. You know how when we have many-to-many in a relational database, we have to create lookup tables or an intermediate table is an issue. The network database does not have this problem. It's designed to quickly handle multiple people owning something, multiple people having possession of a record or something like that, which is in the real world. You think about, like in a Git repository, you're working on programs together. Multiple people are in the program. Multiple people are writing policies, procedure manuals. There's not one person doing this. They're owned by many things, and they're possessed by many things. So this is kind of the anti-hierarchical model, I'll call it. So this is designed for the kind of the more robust free world mentality out there, where open source tools, those kind of things. We want to look at all the people contributing to open source projects like GNU and stuff. This is the kind of database you would do that would make it easier for you to trace back and handle all of that. And finally, we're going to look at document database. Document databases, a very popular version of this is MongoDB. You may have heard of. That's document databases are also called document-oriented databases or document stores. They are non-relational, or what's known as NoSQL. Think of a documents like objects in OOP, an object-oriented program. That's what your documents are like. Normally, the documents are stored like in a JSON, XML, or BSON type formats. We can take a look at some. It's like these would be documents. Java, the complete reference. This is like a JSON thing, or dictionary type, and this is how they're stored. And the document databases typically will use our old friend here, the inverted index, as part of the process so that you can quickly dig through all these documents and make sense and make use of it. Because otherwise, just storing a bunch of documents in a folder doesn't do you a whole lot of good if you can't like read them and make sense of them. So big difference here. I pulled this from a site where your RDBMS, which would be your relational databases and your document database system. So you're structured around the concept of relationships, where the document's focused on data rather than relationships, organizes data into tuples or rows. Documents have properties without theoretical definitions instead of rows. Defines data in forms, relationships by constraints and keys. Child table references the master table and its ID. And no DDL language for defining schemas in this. So remember DDL, data definition language. That's how we create our tables. We alter our tables. That's how we assign keys. It's all in the data definition language, and it builds our schemas. And again, so here, NORIAR uses data definition language to create our relationships, and relationships represented via nested data, not foreign keys. Any document may contain others nested inside of it, leading to an n-to-one or one-to-n relationship between two document entities. Again, the many-to-many doesn't really break the document store. And so the RDMS offers extreme consistency, critical for some cases such as daily banking and stuff. We don't want errors. And that's part of the RDBMS is I don't want duplicates. I don't want errors. I don't want misspellings. I want my database to be what they call the golden source of truth. Whereas your document database offers eventual consistency, but during a period of inconsistency. And the period of inconsistency is not just the beginning. It's every time a bunch of new documents are added until the database itself kind of works through how everything is related to itself and processes through these inverted indexes. It can be touch and go at times, and then you have to work when you have to come into that mentality when working with things like big data and stuff, because if you come from the world of relational databases, then you start dealing with things like Splunk or these document databases where it's these big data type things. It's a bit disconcerting at first because you're just, it's like, all the rules that you had to apply to, they don't really apply anymore. And they're, so you have to it's a change of mindset is the best way I can describe it. So I have one other thing to add. This is it for the slides, but I want to point out that I'm going to bring this up here, that I did for you guys, and I'll put it in the comments down in the database, under my website, and I think I've got the wrong thing. So analyticsforall.org. I'll put the links down, but I wrote up sorry about that. I wrote up a bunch of articles on graph database. You can see I have relational inverted index. And so you can kind of read through if you want to get more details than what I just kind of blew through on the talking points here. That's available to you. I'll make sure it's free. I'll put it up there. And thank you very much. I look forward to seeing you next class.